So I'm going to use the food analogy. Burgers and fries, you know, they're good together and great together, but you can always eat the fries by themselves and taste just as good, right? So actually I thought we should play a little bit of bingo, but I think we're running late, so we'll skip that. Lots of buzzwords, lots of things that is required of the wireless LAN products and the portfolio these days. We have evolved and come a long way from where we started, I don't know, 10 years ago, whatever. 11N is, you know, done. 11AC is here. Unified access is talked about everywhere. Avaya, particularly after all we have heard in the last section, we are very well poised between the Fabric Connect, Fabric Attach, and our wireless LAN solution in conjunction, working together. We got a very solid unified access story. But what I want to spend a few minutes talking about is the actual wireless LAN portfolio. And talk about how we got everything we need to build a solid, high-performing, and scalable wireless that addresses all of the RF needs, all of the application needs, and so on. So I'm not going to spend a lot of time talking about all these things because you're probably going to hear a lot about it today. Besides, we have built this into every single product that we have on the wireless side. But let me quickly walk through what we have in our wireless solution. So wireless solution is basically includes 5 different access points. We got 11N and 11AC access points, 2x2 options, as well as 3x3 options. We actually have, commercially, we have the ability to actually purchase 11N today and move over to 11AC at a later point in time by actually applying a license upgrade, which is really very nice for customers that are not ready to move to AC yet, but want to have that investment protection so they can move on at a later time, but still just cater to the 11N clients that they have today. Have a range of external antennas, so we can use them, use the APs indoors or outdoors. The outdoor APs are hardened. The whole range of antennas for directional as well as omni. So we have all of that. The management system provides the configuration, the provisioning, the monitoring, the whole 9 yards. It's a VM-based solution. And Vamshi will actually be showing a little bit of the management system as time permits. We also have a Wi-Fi designer or the site planner that allows us to build site plans just in case, you know, a customer decides to do it themselves, which generally is not the case, but in case they do, we have that as an option. So basically, we got, you know, a chock full of feature sets. We have full support for BIOD. We have identity engines, which is our access control solution. So the wireless LAN in conjunction with the identity engines provides you full BIOD onboarding, the whole 9 yards in that regard. The Bonjour support, you know, stuff that is expected to work these days, especially for K-12, that's built into the solution. So we got all of that. Now, I want to talk about, just spend a few minutes talking about some of the advanced features that make our solution, you know, addresses the key important features and requirements of a CIO as well as of a network administrator, right? Saving money, very important. Being able to deploy wireless LAN very, very quickly. You want to get 300, 400, 500 APs in a building in less than a couple of days. You want to do that quickly. Of course, you can use unified access to, you know, hurry up and get your whole configuration done. But you also need your AP configuration, your RF configuration, and so on done very quickly. So it's important to have a management system that allows you to do that. So we have all of that built into the solution. Most importantly, Alan mentioned earlier in today's session about, you know, the whole application control and what that means and why that's so important. There's a lot of mix of, you know, recreational applications and productivity applications going on at any point in time in any environment, whether it's schools or healthcare or corporate offices. It's almost as ubiquitous as wireless is today. So it's really important to be able to detect what's going on in your wireless at any point in time. So now RF is not your only problem. Applications are your problem as well. So being able to address the RF and address the application are very, very important so that you can keep your network clean. With that in mind, what we have is a very strong suite of application control, application QoS, and application management solution that's basically built. Maybe I'll just go on to the next slide and talk about this and then come back. That's basically built in a way that you can run this. This is load balance between the multi-core CPU on the access point. So the way we run the application control, you can set as many filters as you want. We have a deep packet inspection engine that's going to be running between the 2 cores. And therefore, there is no impact to the performance. Because the last thing you want to do is to set up a bunch of filters and notice that all your packets are being dropped. That's not the point of the filters. You want to be able to filter just the ones that you want to block. So having the performance guarantee while you're running these filters, right, you could be blocking a whole category of games. And normally that extends to, I don't know, like 30, 40 different games, which actually translates to 30 different filters. So when you run filters, we all know what filters do to your whole system, right? So you don't want your access points to go down in performance just because you have 30 filters running. So that's why we have the 2-core CPU on the access point. All of the DPI operation goes on between these two CPUs. That keeps the performance at a steady state. So regardless of the filters, Vamsi will be showing some demos later on to kind of highlight that point. In addition to that, we have a whole range of applications. We have about 1,300 applications that are supported by the application control. And the granularity is pretty deep. So you can actually pick and choose whether you want events or notification, audio versus video. So you have that ability to pick and choose what you want and what you don't want. You can also throttle so that you don't piss off your employee or your staff. They can still use the application they want, but you control it in such a way that they give up because they don't have the right bandwidth. So that's the application control. Very, very key to keeping your network network running smoothly these days, simply because there is just such a proliferation of applications. Let me go back real quick and a couple of RF features that I want to talk about. So first and foremost, the whole load balancing piece. So our load balancing basically works based off of not just what AP is in the proximity of this current AP, but it takes into account a combination of the client streams, the number of spatial streams on the client, the RSSI, the band. So the trouble with band steering is when everyone is going to be on 5 gig, band steering doesn't do anything. So you really want to be using a combination of all the attributes of the clients and use that information to be load balancing between the different access points. The other part of the RF capabilities, we also have the ability to do auto cell. And the auto cell, what it does is really control your cell size and your power level so that you can have the most number of clients at the highest data rate possible. Rather than have a longer range with lower performance, lower data rate, you're going to actually try and keep the control over the cell size, control over the power, so that you have the maximum data rates on all the clients that are on your network, on your AP. So this effectively improves your overall utilization of the access point and also provides a better data rate for your clients.
So you're dynamically removing available data rates from a cell?
So we have, what we do is there's a defer threshold that you can set, and you basically use that in your CCA process so that you can actually control, the cell size dynamically.
Your cell size, but you said that you are encouraging...
No, we're not changing the data rate. We're controlling the cell size.
Okay.
And what I meant by the data rate is because you control the cell size, you don't have the long range that is going to automatically impact it.
Okay.
By controlling the power level, correct. And by the same token, the shop cell allows you to basically define a power sector so that you can decide your coverage range. So when you have overlapping access points, you decide how you want your coverage range to be, so that, once again, it's a similar mechanism, but it just keeps your cell size much smaller and decides the boundary for each AP that you want. So the goal at the end of the day is prevent your interference, right, as much as you can, and try and allow as much coverage as possible with as many APs as possible. But make sure that your clients are all coming in at the highest data rate possible at the lowest power possible. So that's the combination of that.
So are you using some sort of mapping software or some management platform so you can kind of put in, when you talk about auto RF capabilities, right? Are you helping that out by showing obstacles? That's a full-on concrete wall that's like 3 feet thick, or
so that would actually be more from a site planning perspective, yes.
Okay.
But not so much in the auto RF. But it does take into account, for instance, the whole cell part of it would take into account abstractions like a wall, because now I don't want this RF to bleed into the other side or another network. So yes, that would take into account, but not so much from a structural standpoint, but more from an RSSI standpoint.
And maybe we're just jumping ahead a little bit here on when you're talking about this advanced RF capabilities. What are you doing in terms of doing a high density type deployment? How are you managing that? Maybe
So
you can talk about that.
that's an interesting question. Our focus is not so much on high density environment. If you're talking about maybe like a conference room or something, some of the things that I just talked about would actually address that. But if you're talking maybe stadiums and kind of really other high density environment with 20,000 fans, we're not so much focused on the high density environment. We are definitely more focused on enterprise, healthcare, K-12, the whole 9 yards, rather than just one segment of the whole customer.
That kind of requires a bit of a different solution. And by the way, we did this at the Olympics, right? We did not only the Fish Stadium, which was where the opening closing ceremonies were, but also the 2 hockey rinks as an example. And we do it much like others do, which is a lot of directional antennas, managing cell size, to not, especially in 2.4, to not get co-channel interference and things like that. So those tend to be a little bit more specialty things. I think if you're thinking about high density as in a room maybe twice as big as this with 50 people in it or things like that, then I think, we can use normal sort of based, auto RF to deal with that. It
would be a combination of, getting the right antennas and getting the cell size right and the transmit power and the receive sensitivity. Yeah, absolutely.
Does your advanced RF algorithm incorporate client feedback, or is it just AP to AP RSSI? It
is including client RSSI as well, yes.
On that same topic, is there any provision for like CCX or any of that extended kind of stuff?
Not at the moment. No, that's not something we would look at. Yeah. The other thing I want to talk about very quickly as well is in terms of getting the biggest bang for the buck, the software programmable radios are a very key feature. And what we feel it's really important, especially at this time where a lot of the wireless environment are going through the transition. You got the 2.4 and you got the 5 mixed client environment. So it makes perfect sense to have your APs, set up at 2.4 and 5. But let's think about it a year from now where everyone is moved on and we all have 5 gig and we don't want to use the DON 2.4 anymore. Now you're talking about every client sitting around is a 5 gig. How are these APs with 2.4 and 5 preset on the radios going to handle that, right? Basically, you have your one radio turned off on these APs. So what we do is provide the ability to the customer to actually set the 2 radios to anything that they want, any band that they want. So you could have 2.4 and 5, or you could have both 5. So for a customer that has a mixed environment today, you start off with setting it at 2.4 and 5, and then as you evolve, you move to a 5.5, and you actually get 2 times as much out of these access points compared to any of the other generic access points that are set at 2.4 and 5. Vamsi is going to show this, how it's done and what it means and so on. So we'll look into that as well. So, but basically the whole idea here is make your deployment easy, right? Keep your costs low. Make sure that there's investment protection, because the last thing you want to do is to upgrade your AP every year. And a lot of customers have already done that, and I think they've had enough of that. So we want to get to a point where you put it up and you don't have to do a hardware swap, right? You want to be able to change things, make sure that the AP is working as the client wants it to work, not in some preset mode. And so save money thus. And also in terms of being able to have that ease of deployment and being able to configure, being able to roll it out very fast. Because all of this translates to money and time, and that's really important. And then, of course, once it's all deployed, you want to make sure that the RF and the applications are controlled and managed appropriately. So you're getting what you expect out of these APs, right? You don't want to put it up, think you're going to get 1 gig out of it, and end up getting like 200 or whatever. So we covered this. And so at the end of the day, what I want to do is leave you with 3 things, right? So application control, application management, being able to adjust costs based on the applications, and figuring out what you want in your wireless network. Very, very important. Advanced RF features, as we all know, very, very important to keep this network up and running. It's no easy task. So it's a combination of things that have to be tweaked to make it happen. Again, very, very important. And as we talked about earlier, the whole unified access story, right? It's a lot like BIOD a couple of years ago. We all said, no, it's not going to happen, but it's here. I think unified access is going to be the same. A year from now, we will all just take it for granted. So between Fabric Attach and Fabric Connect, we have that ability to do that today. So with that, I'm going to hand over to Vamshi. He's going to actually walk through the demo of some of the things we talked about. And
while he's prepping the demo,
yes.
my simple mind just needs clarification here.
Sure.
Sorry. Where is the data plane, control plane, and management plane in your wireless solution?
So ours is a two-tier architecture. So the solution I'm talking about is a two-tier architecture. Basically has your control plane and data plane on the access points. We do have a management system which is running on a VM, so that's separate. And he's going to be showing a demo of that. It's called the orchestration system.
So, but then you also had the identity, and Jake asked where the policy is. It was in identity, but management someplace else?
So the identity engine is actually an access control solution, and that's the overarching the access control solution for the entire network, wired and wireless. So it's a completely separate policy engine access control solution.
Then there's a wireless NMS.
The wireless management system is a separate management system, correct?
Yeah, so kind of three components. Yeah, identity engines, which is the .1x that actually helps with fabric attach. Sort of all your main policy engine for onboarding clients' devices, even core to fabric attach. You have a wireless orchestration system, which is essentially the management plane, and Vamshi is going to show it to you for all of wireless. So, configuring SSIDs, security policies, all of that. And then, of course, the data plane is all in the APs themselves, and they interact with the wireless controller system. So, and then what you saw earlier was how fabrics can actually help accentuate the provisioning management, even collapsing of the two networks together. Not required, but those are kind of, as an independent solution, you could either have just wireless orchestration and system and APs, or you could add identity engines.
So if an AP hears a neighboring AP on the same channel, who tells it to change?
So the APs actually are exchanging information over the air. So they are building their own database of the RF.
So there's more of a protocol between the APs who are working on auto RF.
So there is.
So they don't have to ask over the orchestration system.
Absolutely correct.
They
Yes,
do
that's a very important point. Yes,
Okay.
it's over the air. It's not the orchestration system simply manages and pushes out the configuration and monitors. So all of these algorithms, so the RF and some of the other things that are happening dynamically, they are happening over the air.
And how are those APs discovering themselves, and how are they communicating with each other? Are they discovering over the air and then communicating over the wire?
So they discover over the air, and then whether it's the auto RF algorithms or the roaming algorithms that, the roaming information that needs to be exchanged, that happens over the air. And it could be, the APs could be in the same subnet, or they could be across multiple subnets. We are discovering the IP addresses over the air, and as part of the information exchange over there. So even if it's another subnet, the APs can't, discover it. Now,
We can actually show some of the configuration. So you can actually pick and choose whether you want just a few of the APs in the neighborhood to be participating, or you want the entire VLAN, or you want the entire subnet. So those options are there. But let me hand it over to you, and you have your mic. Okay.
Yep.
Thank you.
Thanks, Jayanti. So in the previous session on our SDN and fabrics, we kind of demonstrated how this whole network and the switch can be automatically configured without having to touch. In this demo, I'd actually want to focus on the specific wireless LAN features. So I've logged into our orchestration system. The orchestration system is, built of dashboards. Each one of these little things is a widget. You could create widgets, you could move them around, you could customize them to say, I want an entire networks view, or a specific profile, or a specific scope of access points. So, and then, you could dig through into further details, right? So, and this is pretty much, I think, every standard orchestration system or a management system today has these features. So during this demo, I'll be focusing on three features. The first one is our honeypot feature. I think, some of you probably experienced this when you came in. I think it's a security concern for some of you. You probably might not have liked it. We just wanted to demonstrate it because there's, it's kind of it falls into the ethical hacking category, right? So in the sense, it's not your hacking in. So honeypot feature, right? So what's the main advantage for honeypot feature? People who are traveling all around, you're connecting to a lot of open SSIDs out there. So now when you come into our network here, if you're not actively looking to connect to this network, your device in the background is probing for all these things, right? So this just to demonstrate, it's like, hey, you know what? I think Dean walked in yesterday and he was seeing SSIDs populate, where he connected over the last 2 years. So what's it doing to the network? It's actually using up your airtime, right? So it's impacting your network. And when you talk about a conference room like this, where there's a lot more devices that are coming in, that can impact your AP performance.
Well, it also impacts your user experience as well,
Yes.
right? We have international users here who need to get online to get an email to get their credentials from the guest sponsorship, and they can't, so they can't tether up. For example, I couldn't turn on tethering on my phone, and they couldn't connect to it because you hijacked my SSID,
Oh, sure.
right?
Yeah, so that, so I'll just get to that in a minute, right? So essentially what we're doing here is the honeypot feature. It's kind of, it's configurable. It's, you enable it and disable it. It's probably not applicable to every use case. There's specific use cases where you might want to do it. And there's three things that we can do, right? So we can just connect it, put you in a black hole. We can just let you connect, and we can push you a splash page. That could mean I'm pushing advertising to you. That means I could be pushing other things. So I'm letting you connect, but I'm pushing you that. Then you could do what we did today. Is it's like it's automatically redirecting to so the guest portal as you see in here, right? So whoa, and I'm still connected to a Marriott SSID here if it comes up. But I think you've seen through this, right? So can you just check that? So when you walk into a stadium or a large conference room, it's improving your performance. And when you are specifically addressing the use cases like an international user, that's actually being done by the guest manager, right? So that's actually the captive portals policy that Avaya's IT has set up, and that's not that could be configured in either ways, right? So it need not be an international cell phone, things like that.
Can I ask a question? So you said, that those probes were taking up airtime. Mm-hmm. Don't you have to, when you're doing like a honeypot type of method, don't you have to continue to beacon for those SSIDs to keep those clients associated?
No. So the way I'll just show you, when I go through the configuration. So what we are creating is a honeypot SSID called honeypot. It's not broadcasted. So we are listening to the probe. So if I'm probing for Marriott or if I'm probing for Starbucks, I'm responding to that probe. So it's the client that's initiating. And even if I don't do that, the client's actually doing these probes and it's using up airtime.
So how is it saving airtime if you're sending a probe response back for every probe request?
So once
Why don't you just ignore them, and that's even less airtime?
No, so I'm just responding to this. So once the client's connected, now you're not going and probing for all the other SSIDs. Your frequency is less because you're already connected. You got an IP address. Now you are sitting in a page where, hey, I'm logging in. So this device that's connected here is not probing at the same frequency. It's not looking for every other SSIDs because now it has a Marriott SSID it's connected.
It's upfront pain instead of the ongoing pain of beacon.
It's coming. Okay.
And one thing I want to point out, right? It's just a nifty feature.
Microphone.
Yeah. I think it's useful for some of the high density deployments. So the orchestration system that we have here, this is the network that is providing services to a section of this building. There's total 10 APs. There's 8 APs in the floor where the wireless LAN and some of the unified access team sits. And there's actually 2 access points in this EBC where all of us in this room are also connected through. So there's 57 clients that are on the network. Now, when we talk about software programmable radios, and you can clearly see as to why what we're talking about, right? So there's 57 devices on the network right now. There's, if you really look at it, there's 11 that are 2.4 and there's 46 that are 5 gigahertz. And, there's like only 4 11AC devices right now. And, I see a lot of Macs. So the fact that Apple hasn't come out with the iPhone and the iPad, once it comes out, I'm pretty sure that number is just going to skyrocket. So what are we trying to do here? But when you're doing a standard deployment, 2.4, we are always positioning the APs for coverage for 5 gigahertz, and we tune. Even in today's environment, we tune the 2.4 radios or shut down the radios. So what I want to essentially show is, the 5 gigahertz radios, the access points actually operating on this, right? So as you can see, of the 10 access points that we have, there's actually quite a few access points that are operating in this network that are operating on 5 gigahertz on both the radios, and it's actually servicing clients. Of the 2 access points in the EBC, one of it's actually operating in 5 gigahertz mode, and then the other one's actually in 2.4 and 5 gigahertz mode. So that essentially is showing that, hey, these APs can work. We have all the issues that need to be addressed are addressed so that they're fully functional. Okay. And then the last thing that I want to touch upon is our, the whole application control, right? So as you can see, right, so in here, we provide full visibility. So this is just the application usage of the environment here. I think most of you are, on the social networks right now. So you see a lot of social network usage as well as streaming media. We can categorize the applications, at a broader level, at a category level, as well as individual applications. So this is providing us the visibility of what's going on in the network. And this is just like the top 10 applications kind of a view. But as soon as application control is turned on, it's actually showing me the entire application usage, right? So the DPI engine, as Jayanti mentioned, we can classify up to 1,300 access points. Sorry, 1,300 applications. So as soon as the DPI engine is turned on, the classification is happening for each of these applications. So you can come in here, you can see which applications are being used, and as a network administrator, you can decide whether you want this application or not, as opposed to figuring out first which applications you want. And it's like 6.43 GB of YouTube data. So now how do I set it up, right? So we have policies, or application configuration profiles. This is what you set up even for the FA. So when we talked about the policy engine, we can come in here, create a profile for this site, and as APs are plugged in, this profile is automatically pushed to each of those. So, in the rest of time, I'm not going to go through all the other configuration settings. It's pretty much, all the knobs that you need to tune your, the radio and the channel and the security policy all there. I just want to walk through the application control portion of it, right? So I have two filter lists. So the applications are enforced as part of the filter list. And there's a reason why we kind of do that. So within the application control, there's three things that we can do, right? So there's something called preset filters. So there's a lot of broadcast, unnecessary traffic that gets onto the air. So the preset filters, what we have is, we have something called a group of air cleaner filters. What it's doing is, it's, when I add it, it adds all these policies that you need to clean up the air, broadcast, ARP requests that are going, all the chatter that needs to go on that you probably don't need to get over the air. You want web-only traffic, you don't have to create 10 policies. You can just click this one button, and that's adding all those 10 policies. So
that's just, you're just talking about just cleaning the
that's
traffic
just the
on
clean
the
air,
SSID itself,
that's just
right?
the clean air thing. Hold on something. I think I'm running out of time, but just 2 more minutes. So what's happening on the network, right? So just to kind of give you an indication of the performance. So all those clean air filters have been applied here, but I've also created certain policies, just to give you an indication, right? So there's filters that are in place to block all BitTorrent traffic right now. There's filters that are, so that's an individual application that I'm blocking. I'm blocking all the gaming applications. So I'm doing this at a category level. So if I look at this individual filter, I can actually see that all these applications are actually being blocked. It's not just one of these applications. And then let me cancel here. And then the last thing that I want to show you is here, it's not just about prioritizing blocking or denying traffic. We can redirect specific traffics. So protocols like MDNS, link local multicast, where you don't want to mix it with your unicast traffic, you can create a separate WLAN that gets extended to your fabric, things like that, so it's easily attached. So these are the key things that I want to show. Thank you.
So we're trying to be sensitive to time as well.
Yeah, I think
because we're about 15 minutes. So hopefully we showed you something you're interested in. And one thing I do want to make sure that I'm very, very clear about, because there were some questions about. So this AP that we showed doing the demo, the same AP does all the traditional tunnel functionality, orchestration, plug it into a traditional IP network from anybody, and it'll do all the things that we expect, and you're probably hearing from other vendors as well. It'll also work in that other mode. And that's the point of that initial step of configuration to orchestration suite, so that you make the edge zero touch. You have to do that first phase of configuration, and then you just plug it in. So it's a nice way of simplifying the lives for our customers who have embraced the fabric, and we're seeing that growing quite a bit. Are there any questions before we close off completely, or I hand it back over to the matron?
Yeah, when you say it's just like everyone else, other Wi-Fi vendors are proud of their extra features in their radios, their antennas, the chipset development. How big can you tell us? You talked about the FA side.
I did talk about the FA
Let's
side.
talk about this is Wireless Field Day. What's that special about that
That was one thing
Wi-Fi?
we're trying to. We purposely didn't bring RF guys to the room because we wanted to show off what we thought was cool about what we were doing and focus on the area that we see most people asking us for that type of innovation. Do you want to add anything, Alan?
Yeah, so I'll just summarize, and I think this slide is, so I think, what we're doing with application control, we think is pretty neat. I talked to a lot of customers. This is really valuable to them. The fact that we can do 11N to 11AC for some customers aren't quite ready to take the jump is interesting. The software programmable radios, some of the, honeypot features and other things that Vamshi and Gianti talked about. So some of these kind of advanced RF things. And then, of course, we really do believe that a core innovation and building block of what we have, it really is our fabric technology, and we think that we can really enhance the wireless network by truly unifying kind of wired and wireless. So that's really, we're trying to think about this much more than just a wireless system. We obviously sell a lot of wireless systems as standalone entities, but we're really, driving towards how can we make the overall networking experience better.
Get
it?
Sorry to be mean, but you didn't answer my question. My question was what's the unique features RF-wise, antennas, and all what do you do in your APs that make them special? Because I'm a firm believer Wi-Fi's best part is layer 1 to layer 2. Once it becomes the Ethernet frame, then all your wonderful stuff works great.
Absolutely.
But Wi-Fi is about that first little bit.
It is, yeah. So some of those. Yeah, so some of the features that we talked about really are the antenna feature, like the 2.4 to 5 gigahertz is kind of an antenna feature to be able to software program those radios. I think,
that's like, share more of that.
Share more of how that works?
No, I mean, right. Not everyone has a software definable radio that can do both 2, 4, or 5 gig. That was unique. That was something that you do that other people.
And that's why we call it out. That is not only unique, I think
So good point. We should have spent more time on exactly how that worked and what we've done from an antenna design perspective, right? Because we do just like everybody else. We spend a lot of time trying to make sure that rate and range and all the kind of RF characteristics in terms of the plot and everything work well in an environment. Because I agree that your first level of experience is that RF, right?
Yeah. Sorry, that's why we're here. So yeah.
Fair question. Anything else before we conclude? Great. Thank you all for being here today. We appreciate you giving us the time to meet with you and talk about our wireless solution.
Thank you.